I will go through 3 extra examples now. Our first example, or our first extra example, it's about a pail of water which is rotated in a vertical circle of a radius 0.7 meters. What is the minimum speed at the top of the circle if no water is to spill out? Now, at the top of the circle, here's water. Now the forces, this is the radius r, the forces acting on the water are mg down and the normal force n. As long as the normal force is greater than or equal to 0, the water stays in the pail. If the normal force drops to 0, then the water loses contact with the surface, and the water will simply leave the pail. So, no water spills out means that normal force Fn must be greater than or equal to 0. As long as Fn is greater than 0 by a very tiny amount, the water stays in the pail. When the normal force becomes 0, the water begins to lose contact with the bottom of the pail, and so the water will spill out. Now, since this is moving in a circle, we have the force down when it's at the top. That's all towards the center. So we have mg down plus Fn. This is equal to mv squared over r. So this means that since I want Fn to be greater than or equal to 0, this means that mv squared over r must be greater than or equal to mg. As long as mv squared over r is greater than or equal to mg, then this means that Fn will be greater than or equal to 0, which means that the water will stay in the pail. It will not lose contact with the bottom of the pail. So this means that v squared must be greater than or equal to gr. So this means that v is greater than or equal to square root of gr. So the minimum speed at top of the circle is square root of gr. That ends extra example 1. All these problems, when an object, when something loses contact, that happens when the normal force becomes 0. As long as the normal force is greater than 0, even by an infinitesimal amount, the object does not lose contact with the surface.